Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 12 patterns, sequences and series, a revision of quadratic number patterns. The question that we are going to be looking at today appeared in the February-March 2016 examination, paper 1. And it reads as follows. It says, given the following quadratic sequence, -2, 0, 3 and 7, write down the value of the next term of this sequence. Now, when it comes to a quadratic number pattern, and as we learned in grade 11, remember that for a quadratic number pattern, the second difference is constant. So the second difference of our quadratic sequence is going to be constant. Now, a sequence is going to be where we can predict future terms by looking at the previous terms. Remember the difference between a sequence and a series, that a series is going to be summed up or added up. So they are generally separated by plus signs. A sequence is basically separated by our semicolons. Now if we quickly just look at the work schedule, it says patterns, sequences and series, and this is the most recent one, the 2021 work schedule. And under pattern, sequences and series, as you can see, it says that we need to look at arithmetic, geometric, sequences and series. And the first thing that we have to look at as per our examination papers would be our quadratic sequences or number pattern. So let's get back to our question. It says, given the following quadratic sequence. Now, what I would suggest you do here is write out your sequence in a manner in which you can now expand it, and you can write out the first difference and the second difference, etc. Now remember, n is the position of the term, tn is the term in the sequence, and then we can work out our first difference. So we got how many terms here? 1, 2, 3, 4 terms. So we're going to say 1, 2, 3, 4, and our term is -2, 0, 3 and 7. Now it says write down the value of the next term of the sequence. Now remember that they told us that this is a quadratic sequence. So therefore, as I told you before, we're going to say that the second difference is constant. Now let's work out the first difference. So it says 0 minus -2. Now remember, how do we work out the first difference? We'll say t2 minus t1. So 0 minus -2 is going to be 2. And t3 minus t2, 3 minus 0 is going to equals to 3. And t4 minus t3 is 7 minus 3 is equal to 4. Now, what do you notice about the first difference of a quadratic sequence? Well, the first difference of a quadratic sequence, and this is very important for you to understand, is a linear sequence, which means that in a linear sequence, what we should know is that it has a constant first difference. And that is something important for us for future examples. Now let's work out the second difference. And remember, now the second difference of a quadratic sequence is constant. So 3 minus 2 is equal to 1, and 4 minus 3 is equal to 1. And as you can see, now you've got a constant second difference. Constant means the same. Okay. It says write down the value of the next term of the sequence. So the next term of the sequence is going to be term number 5. Okay, and all you need to do here now is, in order to get term number 5, remember it works like this. -2 plus 2 is 0, 0 plus 3 is 3, 3 plus 4 is 7. So if you expand the first difference, 2, 3, 4, so the next term there will be 5. So you'll get 7 plus 5 is going to equals to 12. So therefore, term number 5, or the next term in the sequence, will be 12. So the answer for 2.1.1 will be 12. Let's write that down. So it will be 2.1.1, and the next term is equal to 12. 2.1.2, it says determine an expression for the nth term of the sequence. Now remember that the general term of a quadratic sequence is as follows. Tn equals to an squared plus bn plus c. I'll write it down again just now. So that's the general term of our quadratic sequence. How do we find these values a, B, and C. Well, I'm going to discuss that with you now. So let's write that down. 2.1.2. So for 2.1.2, remember that the general term of a quadratic sequence is Tn equals to an squared plus bn plus c. Now we want to find these values a, b, and c. Now this is how we're going to find a, b, and c. So let's just check that out. So the first thing we're going to do is step number 1. You're going to say 2a is going to equals to the second difference. 2a equals to the second difference. Now the second difference here is equal to 1. So therefore now we're going to say 2a equals to 1, and you're going to solve for a. So a is going to equals to half, right? Step number 2, your second step is going to be as follows. It's going to be 3a plus b equals to t2 minus t1. Or you can say 3a plus b is equal to the first term of the first difference. And as you can see here, t2 minus t1 is 0 minus minus 2, which is equal to plus 2, which is evidently the first term of the first difference. So that's equal to 2. So what you'll say is 3a plus b equals to t2 minus t1. Now remember, this a over here is this value which you already calculated. That's why you have to be very sequential in your approach. You have to do step 1 before you do step 2. So therefore you're going to say, therefore 3 times half 3a plus b is going to equals to, remember, t2 minus t1 is equal to 2. So you're going to write down here 2. So it's going to be 3 times half is 3 over 2 plus b equals to 2. B equals to 2 minus 3 over 2. And 2 minus 3 over 2 is going to be 2 is going to be 4 over 2 minus 3 over 2 is going to equals to half. So we can conclude there that b is equal to half. So what do we know so far? B is equal to half and a is equal to half, right? There's b here equals to half, and there's a that equals to half, right? Step number 3 is going to be as follows. A plus b plus c is equal to t1, which is your first term. And your first term is this value here, minus 2. Okay, so let's write that down. Now, as I said before, remember, you've got to be very sequential in your approach. So what's a? A is equal to half. What's b is equal to half plus c equals to t1, which is term 1, and term 1 is equal to, where is it here, negative 2. So you're going to say minus 2. So half plus half is 1 plus c equals to minus 2. Therefore, we can conclude that c is equal to, if I bring this plus 1 over to the right hand side, it becomes minus 1, and minus 2 is minus 3. So learners, as you can see now, I've got a, b, and c. A is equal to half, b is equal to half, and c is equal to minus 3. Now step number 4 will just be merely substituting a, b, and c in your general term of your quadratic equation, which is going to be Tn equals to an squared plus bn plus c, your quadratic formula. So it will be an squared plus bn plus c. Therefore, the general term is equal to, a is equal to half. So it will be half n squared plus half n, and c is minus 3. Now at this particular stage, this is your answer. Now you got your general term. So all you got to do now is just test whether it is correct. So what we're going to do is we're going to test our first 2 or 3 terms. So we're going to say half times, so n is equal to 1 means we are finding t1, which is our first term, right? So half times 1 squared plus half times 1, right? And then minus 3 equals 2. So we should get minus 2, and we got minus 2. Let's go double check that, right? There's minus 2, right? So we got our first term there, which is minus 2. So now let's go check the second term out. So you can go back here. So you go and put 2 there now for t2, right? And we'll see now what we should get for term 2. We should get 0 And if you get 0, then you know now that your answer is correct. Now, if you don't get your terms, then you know you made a mistake somewhere. So you have to go and double check now and see where you made a mistake and just go and backtrack and sort it out. Okay, so that's your solution for 2.1.2. 2.1.3, which term of the sequence will be equals to 322? So now in this particular saying the which term, so basically they want you to find n. Right, so all we have to do now is, remember they're giving us Tn, which is 322. So therefore, for this particular question, 2.1.3, it's going to be as follows. 2.1.3, let me say 322, it's going to be substituted there. So it's going to be 322 equals to half n squared plus half n minus 3. So wherever you got Tn now, you're going to substitute that value and we're going to solve for n. So now remember that this is a quadratic equation. So we have to make one side equals to 0. So that's going to be half n squared plus half n. And if I take this 322 to the right hand side, it will be minus 325. Now at this particular stage, depending on what calculator you got, you can either use the quadratic formula or you can use this function here in your calculator, which is also the quadratic formula, but this one got it pre-programmed, right? The silver calculator. So 5 option there, option 5 there. So you put 5 and here you're going to go now to option 3. Okay, so your a value now, the coefficient of, remember n squared is your a value, so that's half. So you can put a half. So 1 over 2 equals 2, or you can just go put 0.5. And then over there for b now, you can also put 0.5. You can put 1 over 2, 1 over 2 there again. And then your c value is minus 325. So you got minus 325 equals to and equals to. So you got n is equal to 25. Remember, n has to be a natural number. Okay, so leave a line now. Remember, you're going to come back and you're going to write your factors here. You have to write your factors. Okay, that's where you get marks there. So you're going to say n equals to, what's that there? 25. So you're going to write down 25, or n equals to, press equal to again, minus 26. So you're going to say minus 26. So write down, don't forget to write down not applicable for your negative answer or answers that contain a fraction, because n has to be a natural number. N has to be a natural number. Remember what a natural number start from 1, whole number starting from 1. Okay, so it goes right up to infinity, 1, 2, 3, 4, 5, 6 and so on. So now go back and write your factors, just change the signs here. So it'll be n minus 25 and here it'll be n plus 26. That's very important. However, if you use the quadratic formula, let's say you got the other calculator, then you can just write down a, b, c, write down the quadratic formula, substitute into the quadratic formula, and then you don't have to write these factors down over here, right? But then you can just write your final answers thereafter. Okay, learners? So the answer there is, so therefore it will be the 25th term if you want to now conclude there. Therefore, the 25th term. And we have now come to the end of this particular video. Learners, if you haven't subscribed already, make sure to subscribe to JL Maths. You can also like my Facebook page, Justin Lazarus Mathematics. You can watch all videos on my website, jlmaths.com, in order of the work schedule. And I'll catch you in the next video.